Mr. Cannabis.
Deep water culture is one of the easiest forms of hydroponics. It suspends plant roots directly into a highly oxygenated nutrient solution. DWC systems are easy to construct and operate, making them a good choice for beginners in hydroponics. This is actually the first type of hydroponics that I tried, and the results were spectacular. Roots benefit from a high level of oxygen provided by the air bubbles streaming through the nutrient solution. Some expert DWC cannabis growers prefer to use heavy-duty pumps to increase the amount of oxygen in the solution, up to 20 to 30 liters per minute or more. However, it's actually not best to release the oxygen directly into the roots, rather circulate the oxygenated water into them. I ended up doing a term project on this, and too much mechanical agitation disturbs the roots and it can actually slow their growth. Plus, as we'll talk about in section 6.3 dissolved oxygen, the amount of dissolved oxygen that can be held in a solution is dependent on temperature, so it's best to focus on that instead of just pumping mad air into your roots. The pH of your deep water culture should be kept around 5.5 to 5.8. You can mount your plants to a fixed cover above the solution, be that a table or a bucket setup. Or you can mount them on a floating platform, meaning that they'll always keep the same contact of depth with the solution. Industrial growers of leaf vegetables like lettuce and spinach use this method in giant rotating tables. In my early years of growing indoors, I actually perfected a method that combines ebb and flow with deep water culture. For me, it's always important to move the water. When root systems get large enough, they become big, dense masses with millions of tiny pockets in them, becoming almost like a soilless media in their own right. So unless you're pumping massive amounts of air into those root systems, which I've pointed out roots don't much care for, you have to find a way to exchange the water from those pockets to keep the roots healthy. This is why I would drain my deep water culture systems frequently. I would have my pump throttled so that the fill rate was the same as the drain rate, keeping my table that was lined with bubblers full. Then every hour the pump would go off for about 15 minutes, taking 5 minutes to drain, leaving the roots exposed to the air for 10 minutes. This not only allows your roots to slightly dry out, but it fully drains all those pockets of water within the root system. And as you can see, the roots loved it. Aeroponics is a method of growing plants in an environment where the plant's roots are suspended in the air and either misted or periodically sprayed with nutrient solution or an aerosol of nutrient solution. This practice eliminates the need for any substrate or growing medium. As a result, the roots are constantly exposed to air, ensuring sufficient oxygen supply, and there's no place for any debris or pathogens to reside. But as we talked about in section 3.5, black root rot and similar diseases can still take hold in this system. Aeroponics offers many benefits, including maximum nutrient absorption for plant roots, massive plant growth due to continuous exposure to oxygen that helps maximize respiratory rates, leading to higher yields and considerably lower usage of nutrients and water compared to those of other systems because of the high nutrient absorption rate. There are two types of aeroponic systems, low-pressure aeroponics and high-pressure aeroponics. LPA is the most commonly used aeroponic system used by most hydroponic hobbyists due to its ease of setup, availability at any hydro shop, and the low cost. The low-pressure systems create a droplet size much different and larger than the high-pressure systems. HPA is a much more advanced type of aeroponic, and it's quite costly to set up as it requires specialized equipment. It's commonly used more in commercial production rather than home growers. HPAs run at a very high pressure to atomize the water into tiny water droplets of 15 microns or less. This fine droplet size then creates more available oxygen for the root zone than LPAs, making them the most efficient system among the aeroponic types. Despite its many advantages, aeroponics still has several disadvantages. Firstly, the initial cost of setup can be quite high compared to other hydroponic systems, which can cost up to several $100s. Secondly, the system requires a constant attention for the pH and EC, as there is such a high nutrient absorption rate. Understanding the right ratio and applying this concept may be more difficult for beginner growers and requires a more technical knowledge. Thirdly, the system does require near constant supervision, as it's highly susceptible to power outages, as there is no medium to hold any water for the roots. Fourth, the system is also dependent on mist nozzles, high pressure pumps, and timers, and if one of those breaks down, your plants may die quickly if not properly monitored, as again, there's nothing to hold on to water to the root system. While I've used a few LPA systems over the years, I've only ever used one HPA system. You have to clean all the nozzles after every grow, or you can get clogs. You also have to mix your nutrients properly, as any nutrients that precipitate out can then more readily clog the sprayers. But man, at 50 microns, it's such a fine, soft spray of water to your roots. Now, speaking of water...
Water.